So this is a quick video talking about similar shapes, similar polygons, which is what you guys were getting when you were doing those dilations. Okay, we're used to congruent shapes when we have rigid transformations. This is a transformation, but it's not rigid. Again, it was called a dilation, and it makes things similar. So we are going to be talking about similar polygons. And when we're talking about similar polygons, these are ones that have the same shape, but unlike congruent ones, they have a proportionally different size. So they are going to be the same shape, but proportionally a different size. And one thing that we do look at is a lot of times we look at the proportions of the sides and we look at the angles in the polygon. What needs to be true is all of the angles are going to be the same. And if all the angles are the same, then the shapes are going to be similar. They're going to be proportionally just different sizes. And when we are looking at actual side lengths, the sides of similar polygons have the same proportion, or what we're going to be calling scale factor for each. It's not like one side's double and another side's tripled. Every single one of these is going to be doubled or tripled depending on the situation. So what I'm going to do is I'm going to look at these pentagons here. And looking at these pentagons all look similar in the sense that they are similar type shapes, but are they really similar? So what I'm going to do is I'm going to get my line tool and I'm going to kind of zoom in here on A, and I'm going to trace I'm going to use the drawing tool and I'm going to hold shift. I'm going to be tracing over the shape. And if you hold shift while you do it, it keeps the lines straight instead of kind of shaky if you're just doing it freehand. And then what I'm going to do is I'm going to take this polygon and I'm going to move it over here to A, and I'm going to compare each of the angles. You see that angle matches, that angle matches, that angle matches, that angle matches, and so does that. So B is going to be a similar polygon compared to A. Obviously, it is a larger version of it. Okay, so let's kind of take a look at C. Let me just kind of move this so we can see C. So if I'm looking at C and I am going to move this, I see that that one, here, I'm going to start it up here so I can get rid of having that in my way. Okay, so for C, I see that the top angle, that angle's the same, that angle's the same, this angle's the same, this angle's the same. So C is also similar. Now, when I come to D, this angle you see is not exactly the same. This one is not exactly the same. Up here, not exactly the same. Okay, they're close, but it's not exactly the same. So D is actually not going to be similar. So the ones that are going to be similar, A, B, and C are all going to be similar. Now, what is going to be true is if I had all of these side values here and I was going to be comparing them, whatever I do, for example, to figure A to get one side of B, I do to all of the ones in A. So let's just say that I'm going to make up some numbers here. Let's just say that this is 2. Make that a better 2. Let's say that this is 2. They look about the same length. Let's say that this is 3, this is 4, this is 5. So if this B is bigger, my scale factor that I'm timesing it by needs to be bigger than 1. Let's say that this is twice as big. Okay, let's just say it's twice as big. So that means every side's going to be doubled. So this would be a 4, this would be a 4, this would be a 6, this would be an 8, this would be a 10, because each of these corresponding pieces needs to be doubled from the original. Each of those is going to be double the original. Okay. Let's say that going to this one here, let's say that it's 5 times bigger. Okay, again, I'm just making these up. It's going to kind of color code. So the 2 is then going to become a 10. The other 2 is going to become a 10. The 3 is going to become a 15. The 4 is going to become a 20. And the 5 is going to become a 25. So all sides are proportional. So if I was to take, let's say my green, I just write it here, 25 over 5 is going to equal 5. Okay. If I was to take a 10 over 2, that equals 5. Everything in polygon C, if I put it over its corresponding one in polygon A, is going to tell me what my scale factor is. Now, if I'm going the opposite direction, so let's say I'm going the opposite direction, let's say that I started with C and I ended up with A, then I am doing the reverse. So instead of timesing by 5, I'm dividing by 5 or multiplying by 1/5. So then let's say I was going to do 3 compared to 15. That gives me my 1/5. If I was going to do my 4 compared to 20, you see that gives me a 1/5. Hopefully this helps you out understanding similar polygons.